Alright, let's check it out. Group number. Oh, what did I not pick on last week? I started and I didn't finish. Group number 6. I don't remember. What's your verbal description for this transformation?
Over here. Yeah.
I know. I keep on.
It's flipped over the y-axis.
Okay. Flipped over the y. Which, can I just call it a horizontal flip for sake of simplicity?
Yes.
But you're right. Flipped in the y-axis or about is the way, or over. I like them all. I like them all, Tyler. You're good. How did you guys do that transformation to these 4 points?
I just multiplied the x value by -1.
Perfect. Because to make it opposite horizontally, take the x value and multiply by a negative. Or think, instead of going left 4 up 2, we're going to go right 4 up 2. You guys see it? Instead of going left 4 up 2, we're going to go right 4 up 2. We're going the other direction for each point. Or like Tyler said, multiply by a -1 and then graph it. So positive 4, 2. So what's going on with 6, 2, everybody? Negative 6, 2. Is that one a little too high? My perfectionist one. Sorry, I'm kind of tall, so everything ends up higher. How about the -2, -2? Positive 2, -2. Are the heights changing at all? No. Just the horizontal orientation as to where they are. Uh-oh, how do we do this one? Yeah, 0 times negative is still 0. It's still going to be right there. And then we can go ahead and connect, connect, connect. If I can do it straight. Ish. Fairly good, right? How many of you amazing ones have like a small little ruler that you carry around? Oh, come on, there are a few of you, aren't there? Lame sauce. Your student ID card? Where's that one? No?
No, my ID card's here.
Make it precise. All right, group number
6. 5.
All right, group number, let's do half of 6. 3. Yeah, that's you guys. No, 1.
2.
Oh. I was looking at you guys. You guys. All right, who's going to speak? Maddie, what's the verbal description? Say it one more time. Okay, so we'll say shift up 4, just for sake of room. But yeah, a vertical shift, good. And how? Going up 4. So how did you guys do that transformation to each of our points? To all the y values. If it's going to be a vertical change, I'm changing the y's, and specifically, how am I changing the y's? Add 4. So each of the y's, instead of going up 2, where's this one going to go up? To 6. So 4 more, right? Instead of going down 2, where's he going to go? Down 6? No. I add 4. What's -2 plus 4? 2. What's -2 plus 4? 2. What's 2 plus 4? 6. Aw, so close. You guys got it? There we go. Yeah? Okay, number next one. All right, he was new, but who figured him out? I'll just take a volunteer. Come on, who wants to show off? Caleb.
I multiplied all the numbers by 2.
Ooh, all which numbers?
Y. All the Y's.
All of them! Now, hold on, that's not bad. We haven't even talked about dilations and stretches and compresses, and compressions. So Caleb, good. Multiply by 2, you got that out of, okay, I'm doubling, but Ricky, why only the y's?
Because f of x is equal y, so when you multiply f of x is 2, it's y.
Exactly. Or think of it this way. If I plug in -4, right? If I plug in -4, f of -4 is who? 2. double it, now it's going to be 4. So it's going to be up. Now don't think of it as adding 2. Think of it as just multiplying. 2 doubled is 4. How about this one? At 6, plug in 6, f of 6 doubled is? How about this one? Negative 2 doubled is negative. Do you see the stretch? Going up and going down. Shift, everything shifts up, everything shifts down, everything shifts to the right or to the left. But with compressions or stretches, everything is getting pulled apart or pushed in. So the 2 is doubled and went up, the negative 2 is doubled and went down. And last but not least, the negative 2 doubled goes down. And so I get my, there we go. There we go. Now, guess what? We have 4 more. So let's pause for a second. Let's go to our notes. I actually want to finish our notes before we go over 1-6 homework answers. I have them all ready to go. Keep your spiral. We're going to come right back to them. But just pull your composition book up on top. We're coming back here to do 4 more. Some of you are like, I need to rewrite the graph. It's getting too intense. That's fine. We'll do that in a second. But right now, let's go back to our notes. We were talking about stretching and compressing. Let's get there. There we are. Distortions. Otherwise known as, this is a nasty mathematical term, dilations. Where it's going with that. Did anybody leave their 2016-17 student planner on Friday? No. Or their shallows book that they know is being useful. What grade is that? Junior? Is it like over and done with? No one's going to do it?
Yeah, no one likes it.
I'll add it in the library.
Shallow. It's a
Yeah, it's AP English and it's
What else do I have? I have seniors, end of the year, 1 day in the life of Ivan Dislanich. I have Hamlet. I have The Sun Also Rises. I have Perlandra. I'll add to it the shallows. I'm going to have like the entire school library by the time I'm done teaching.
What's the sun also
No, the
rises
entire
about?
school library.
Nothing helpful.
It sounds like they
Mr. Littlefield used to teach it, but most people have Little atmosphere got a little sad when he left. Other students. Distortions, dilations. We should be writing. Some of you can't multitask so good. So I don't know. No, you can't. Good try. Some can. Well, he was staring at me when he was. Yes, Chris. She's leaving this week, right? I think she's ready for some dilations. Why is it called non-rigid? We haven't really been talking about rigid transformations or non-rigid transformations, but why would a dilation, from what you've seen today, be non-rigid? Because what? You really tried.
Did you say vertebrae?
Oh my goodness.
It's just not fun.
But let's go with that for a second. Why would an invertebrate be called non-rigid? Think about a worm.
Because it doesn't have a vertebrae.
Uh-oh. Because it can distort in ways that vertebrates can't, right? Okay, so hold on. What's it mean to be distorted or to have a dilation? Is the shape changing? Well, it's right there. Yes, it is changing. For dilations, aka stretches and compressions, I need you guys to think of a rubber band. Yeah?
No.
Why? Remember back in the day when, I don't know how many years ago it was a while, when the silly bands were all the craze, right?
Oh yeah.
Right? The like, little dinosaur ones, everyone would come in and be like, look what happened. They were cute, but I got into it. Anyway, it's okay, I'm an adult. Why am I thinking a rubber band with dilations?
You can stretch them.
Because I can stretch them. So if I was to take, for instance, like what we just had a second ago, there was a horizontal piece, there was a little bit of one up here, and then there was one over here, right? Ish?
Yes.
That's kind of what we had. What happened when we had 2 times f of x? Everything doubled, right? So the bottom part went down as the upper part went up, right? So if I had like some sort of center point of origin, hey, we do in our graph, that stays, but everything just changes. True? Now if it was a shift, like nothing, it's the exact same. Even a reflection, the orientation changes, but not the shape, but distortions. Okay, stretching, that would be multiplying by 2, right? What would this one be, ish? Shrinking by 2. And what would you multiply to shrink by 2? Minus 2 would flip it, right? By a half. Yeah? Now, horizontal. How would I horizontally stretch it?
Put it in the 2x.
Ah, something to do with putting in a multiplication. How do I horizontally compress it? Ah, now it's just falling. Somehow I multiplied by 1 over. Now, do you guys see an outside and an inside multiplication?
Yeah.
Mm-hmm. Me too. If I remember our colors, was green on the outside before? Or was it red? I think it was green. Is that right? Is anybody color coding with me with a 4-color pen? My hero. No. Back in the old days, some kids cared. Just kidding. I don't usually color code as much as I would like. But on the outside, what was I saying? What kind of dilation? Vertical, right? Now, I want you to look at this. If C is a number bigger than 1, like 2, or 4, or 10, or 100, what would we think would happen? 2 times f of x, 10 times f of x, 100 times f of x. We're thinking it is stretching. That makes sense, right? Okay. What if C is, what kind of numbers are in between 0 and 1? Like a half. Fractions that are less than 1, because there are fractions bigger than 1. But like a half, or a third, or a fourth. 5/6. What's happening if I multiply by a fraction less than 1? Shrinking. That makes sense. What's weird down here? A, it's on the inside.
Oh, it's the opposite.
B, it's horizontal. But C, when C is 1, 2, 3, what's it doing?
It's shrinking.
But wait, horizontals are always weird, meaning the shifts. Remember, minus a number, where are you going? To the right. And when you're adding a number, where are you going? So when we're multiplying by something like 2, we're shrinking. And when we're multiplying by something like a half, we're stretching. I'll show you why in a second. But let me help real quick with horizontal. I want you guys to add a quick little note. It's in red, but if you guys aren't color coding, then you better write it. With horizontal dilations. We're under dilations, we're under distortions, we're under non-rigid transformations, the shape is changing. With a horizontal transformation, you have a dilation by a factor of, why am I using factor? What does factor mean? What's going on if you have factors? They're next to each other, multiplied. So I'm talking about factors, I'm talking about multiplication. Factors of 12, 3 times 4, 2 times 6, 1 times 12. Those are factors, they multiply. So by a factor of multiplying by 1 over C. This is why if you have a 2 next to that x, it's going to shrink because it's being multiplied, in a sense, by 1 over 2. Or if I have a 1/2, this is why it's going to grow, because in a sense, it's being dilated by 1 over a half, which is 2. So it behaves opposite what I think. Not opposite as in sign, going a different way, but opposite as in, if I have a 2, it's going to be multiplying the x's by a half. If it's a 1/2, it's going to be multiplying the x's by 2. It's the reciprocal of what you see. Okay? Let's keep going. So, what if I was to give you something like, g of x is equal to 5 times the absolute value of x, and then h of x is equal to the absolute value of 3x. Who's my parent function? Oh, parent function, that was last like Thursday. Absolute value, take away all the extra, the 5 and the 3, and say who's left. So my parent function is, I'm using red as the, hold on, what color do I use? Red, green. My parent function would be absolute value of x. Do you guys remember what he looks like? He's a v. However, when we were just doing all those transformations a second ago in the back of your spiral, wasn't it helpful to work with the points instead of just the shape? Maybe? So let's not think just about absolute value of x as a v. Let's think about it in terms of his actual points. So parent function of absolute value of x. Let me get some tick marks, try to make them as somewhat spaced evenly as I can. That's a little rough. Don't judge too much. Okay. What are some special points of absolute value of x? 0, 0. What else? 1, 1. What else? Can we do 2, 2 and negative 2, 2? And we'll just stop there. That's enough. I mean, that's representative. If we needed to keep going, we'd just be like, right? Put little arrows in the end and say, yeah, it keeps going. We have our representative points. Okay. Help me out. The very first one, aka g of x, the very first transform function. Why am I adding height to my graph? Specifically, I'm going up to 10. How come? The highest I went was 2, and what's multiplying by 5? It's on the outside. I have what kind of stretch? Vertical stretch, and I'm going to say dilation by 5. Why am I saying dilation by 5? Or I could say factor of 5. How is it stretching? All of the points are getting multiplied by 5. Wait, Caleb, hold on. What parts of the points are getting multiplied by 5? Yeah, good, because it's vertical. So, 0, 0. The 0 times 5 still stays. Does that make sense?
Yeah.
Like a rubber band. Except some of you are like, it's supposed to go down. Not always. If it's 0, 0, it's not going anywhere. How about 1, 1? Where's he going to go? He's going to go up to 5. Negative 1's going to, you guys see the symmetry, right? What's on the right side, on the left side, kind of just copy it. And then 2, 2, instead of that, I'm going to have 2. And then the symmetry, I'm going to also have negative 2, 10. No idea, it's not Spanish. Okay, so, then add little arrows. Just kidding, I understand the, oh no, quiz, but come back. I know, he's a little bit skewed, but that's okay. Now, help me out, stay focused. I'm going red for the next one because it's on the inside, which means, verbally,
Horizontal compression.
it's a horizontal compression. Now, some of you would have gotten the horizontal pretty quickly. The compression takes a little bit more mental exercise, a little bit more brain power. So on the page before, we just talked about horizontal on the inside. It works differently than we think. And I don't like saying opposite because in math, technically, what does opposite mean? Negative. Or opposite sign. But that's something ever since probably you were in Algebra 1, even math teachers, we make the mistake of saying opposite when really we mean reciprocal. So I'm going to put in parentheses dilation by what?
It's by 1 over 3.
Good. Flip it. How do I flip 3? Some of you are still kind of stuck on that. Remember 3 over, there's no denominator, so I understood 1, right? Like I understood you in English, I understood 1 with a whole number. So then 3 over 1 is 1 over 3. And you find the reciprocal. But how do I do that? It's on the inside, so I'm only changing what parts of my points?
Yes.
The x value. So take a representative point like 0, 0, well, times anything. Okay, that one stays the same again. But take the point 1, 1. It maintains the height of 1. The y's don't change. So what's the new x value? Not 3. That'd be a stretch. 1/3. Oh, poor little guy. Right? So if he's 1/3 on that side, 1/3 on this side, because there's that symmetry. Now go to 2, 2. Maintain the same height, but what's going on with the horizontal coordinate, or 2? It's 2/3. Pretend it's a third. Here's something to keep in mind. For some functions, I can't say all, but for some functions, depending on their symmetries, question, is that a horizontal compression? Yes. But couldn't that have also come from a vertical stretch? Doesn't a vertical stretch make it narrow and taller? Interesting. So for some functions, you can actually explain it 2 different ways. However, it was given to us as a horizontal compression. We did it as a horizontal compression, and we totally got the right graph. I just wanted to kind of show you that in the sense of, it seems like they're behaving the same way in that both the stretch vertical and the horizontal compression seems to both be making the graphs of my absolute value taller and narrower. Isn't that true? Not by the same factor, right? They're not the same points. But they seem to be doing kind of the same thing. Dilations. What? We're done? Oh, that's not homework 6. Lo siento. It's homework 7, right? Why don't you guys get back in your spirals? Keep those colors out because we're going to go back to grade our evens in section 6 in just 1 second. Get back in those spirals. Now, some of you who are like, this is too much. I can't go more than 3 on 1. Can you draw the graph again, please? If it's too much, just draw the graph again. I don't mean like all the graphs. I mean the parent function, right? So let me get that back for you. If you're getting too many colors, get the basic graph. Get the basic graph. It's okay. Sometimes there's just a lot going on, but some of you are like, no, I got this. Okay. I'm going to do it too, but some of you, it's going to be too much. So go ahead and graph the parent function again.
Is sections 6 through 9 going to be another quest or a test?
1, 1, and 1, 10. But the majority will be the second, with a view from the beginning. And you guys are actually getting back today's chapel. They won't have a lot of time. But you're going to get back your quests tomorrow. You're going to do some corrections on them to figure out what you missed. So it's kind of like it was, I made it worth a lot of points because there's a lot of sections over 1. So I made it worth a half test. And then it'll also hopefully let you have some easy questions on your next test. Does that make sense?
Is it on Red?
Not yet. I always like when you guys see it first. That's just a me thing. But I know some of you would rather have it on Red first. Go see it. I can't make everyone happy. No one can. If you think about it, being happy isn't always a good thing. Did I never write letter C? Guys, how would we properly state then this too?
Wait.
Oh, we did? It just disappeared?
Yeah, it's
Yeah, it will.
Where did it go? I have it here. I still can't vote it.
Oh, yeah, we did red.
I'm going to say by what? By a factor of 2. Vertical stretch or dilation by a factor of 2. Vertical dilation. Oh. That's sad. Beware the dilations. Okay, so. You guys ready to keep going?
Oh my gosh. Oh, I still want to put this on 1 though.
It's okay, Tyler, I'm going to, but some people it's a little too much.
What?
Same time.
Alright. Number next one. Oh, did I just steal a point? I just stole a point.
Negative and then x minus.
Hold on, I need some more colors. I need you guys to think through. Letter D is a little bit harder. How come?
Because
Ooh, there's two things. There are two things, I should say, going on. This now begs the question, does order matter?
No. Yes.
It
Wait,
does.
order for what?
Order as to which transformation to do.
Oh.
Horizontal.
Now, hold on. Let's verbally think through first what's supposed to happen. Alright? What do you see? I see a flip on the outside, multiplied by a negative on the outside, so a vertical flip. And what else do I see?
The translation 4 to the right.
A translation 4 to the right. Now, question. If I was to, and to be honest, order does matter, but technically not always. If I was to take this graph, shift it 4 to the right, and then flip, would that be the same thing as flipping it and shifting it 4 to the right? Oh, you don't need to stress, right? You can do whichever one you like. The problem would have been if it had been a horizontal flip 4 to the right. Might be different than 4 to the right, horizontal flip. Okay, so when they're going the same way, we're going to have some trouble. But right now they're going oppositely. Oppositely? I shouldn't say that. Differently. What do you guys want to do? Flip it and then move it?
Flip it and move it.
All right. How do we flip it and then move it? Point by point. Meaning, negative 4, 2. Instead of going up 2, it's going to go down 2. And shift how much to the right?
Oh, 4.
4.
Oh my god.
Down 2 to the right 4. Some of you are on a new graph, hopefully it'll be better. So flip down to negative 2, and then go right 4. Okay, you should be at the point 0, negative 2. I'm going to go to the next point, negative 2, negative 2. Flip up to negative 2, positive 2, and move right 4. 0, negative 2. I'm going to flip up to positive 2 and move right 4. 0, negative 2. Oh, I did not go over. Where's 0, negative 2?
Oh no,
You guys see it? Yeah, I used the wrong point.
Oh no.
0, negative 2, positive 2. There we go. Right 4.
I have so many bad points.
Wait, how'd you get from?
First point.
The first point.
Yeah, so I went negative 2 and right 4. Then I went positive 2, negative 2, positive 2, right 4. Then I went 0, negative 2, positive 2, right 4. And finally, 6, 2 becomes 6, negative 2, and right 4.
Wait, what?
Let me label my points. I have 10, negative 2. I have 4, positive 2. I have 2, positive 2. And I have 0, negative 2. And if you guys think about it, it's each one plus 4 multiplied by a negative. 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 Not bad, right? But some of you are like, I'm going to keep mine on separate graphs. It makes way more sense. Totally fine. But we had a vertical flip. How?
I just like plug it into my calculator.
But there's no function.
Sketch.
Well, you put in those. Oh.
There's no function on purpose.
You put those points into like stat plot and then.
You gotta be kidding me. This is so much harder. All right.
I would
Stop.
do that.
Stop. Now, kiddos, we're not going to do the last 3 graphs. It's probably going to be our warm-up tomorrow because we're running out of time. However, I need something. Struggle. Can we verbally describe letter E? Vertical change, but how? You see a minus on the outside. So I'm going to go down 3. What's going to be the next one? I'm going to have a vertical flip. If it's vertical and down, I'm going to have to be careful. And then last but not least, you're still here. What's going to happen on this one?
compression by 1/2.
Horizontal compression by 1/2. What did we not get to do today?
Homework.
Homework check, but guess what? What's due by tomorrow?
7.
Homework 7. We're going to go over evens on 6, evens on 7, and get into section 8. Sound good?
Yeah.
Oh, you still have 10 seconds. You guys are so
I'm
antsy.
just stretching.
Uh-huh.
Yeah, I gotta stretch.
You can leave last. Ready, set, get out of here. 5 seconds. Bye.
Thank you.
5 seconds early, that is.
I know, isn't that unheard of? Man, who does that?
Always think they do. Oh, no, it's not. It's the thing.
Chapel day.
And nutrition.